This is a very interesting question. In this question, our target is to find the resultant force acting on the 10 coulomb charge. If you look at this figure, we have three charges: 10 coulomb, negative 16 coulomb, and negative 20 coulomb. They are separated by a distance of 2 meters and 3 meters, as you can see. In this question, our target is to know the resultant force acting on the 10 coulomb charge. So let's investigate it. Between the 10 coulomb charge and the negative coulomb charge, what kind of force exists? Of course, we know that unlike charges attract, while like charges repel. So in this case, this is positive charge and this is a negative charge. It means there will be attraction. Negative 20 will be attracted towards positive 10, while positive 10 will be attracted to negative 20. In other words, the force that will be acting on the 10 coulomb charge will be acting towards the right based on this negative charge of 20. So let's call the force acting on the 10 coulomb charge as a result of the influence of the negative 20 coulomb charge F1 to the right. Similarly, the negative 16 coulomb charge will attract the 10 coulomb charge to the south. Let's call that force F2. Now we have two components of force: the east, or the one to the right, F1, and the one to the south, F2. Let us find these individual forces. First, what is the force? What is the formula for the force that acts between charges? According to Coulomb's law, the force of attraction or repulsion F is equal to the electrostatic constant, or the Coulomb's constant K, times the charge in question times the second charge acting on it, Q1, Q2, all over R squared, where R is the distance between the charges. In this case, we are considering the 10 coulomb charge. So we are going to be looking at it as Q1, while either negative 20 or negative 16 becomes Q2 while looking for F1 and F2. First, we start with F1. So F1 will be equal to K, the constant, is given by a value 9 times 10 raised to power 9, times Q1 is 10, times Q2 for the F1 is 20. Now, we've taken out the negative because the negative only helped us to understand the force that existed. It is not to be considered in the calculation. So long you've used it to identify the direction, it is no longer needed in the calculation. So we are looking for the absolute value of the force, all over 3 squared, because the distance between this and this is 3 meters. If you put this value into your calculator, you are going to obtain F1 as 2 times 10 raised to power 11 Newton. This is physics, it is not mathematics. So how you solve this problem mathematically isn't an issue. You can use your calculator very well in physics because you are not solving a mathematics problem, you are solving a physics problem using mathematics as a tool. So no one is testing your knowledge on mathematics, so make good use of your calculator. Now we are done with F1. Let's look at F2 between 10 and negative 16. F2 now becomes, the constant remains 9 times 10 raised to power 9 times 10 for Q1 times 16, now representing Q2 for these two charges, divided by 2 squared, the distance. Putting this value into your calculator, you have that the force is 3.6 times 10 raised to power 11 Newton. Now we know F1 and F2. These forces are acting on the charge of 10 coulomb, but the charge of 10 coulomb will not be confused on whether to go to the right or to go downward. Definitely it will move in a single direction. That single direction that represents the effect of F1 and F2 is what we call the resultant force. That's what we are looking for. So let's call that force F. It will act in between. So the object will be, this charge will be moving in this direction because it can't go east nor south. It will go in between. But we don't know the angle it will be going through. So we are going to start by calculating the magnitude of the force F. If you look at this, we have a triangle at the top. We also have a right angle triangle at the bottom. It means we can solve for F using the Pythagoras theorem. According to the Pythagoras theorem, F will be the square root of the square of the two forces F1 and F2. So if we put the values, the F1 is 2 times 10 raised to power 11, we square that, plus 3.6 times 10 raised to power 11, we square it. You put this value in your calculator, you're going to have the square root of this plus this, and that becomes the square root of 16.96 times 10 raised to power 22, and the square root becomes 4.12 times 10 raised to power 11 Newton. So this is the force, the magnitude of the resultant force acting on the 10 coulomb charge. But we don't really know the direction, so let's look at the direction in the next page. So let's call that direction theta, the angle the force makes with the vertical. The force is 4.12 times 10 raised to the power 11 Newton. Let's find the angle theta. If you look at this lower right angle triangle, where this is F2, this is F1 because it's parallel to this, and this is F, we can do opposite, which is F1, over adjacent, F2, and that is tan. So if we bring in tan theta, it will be equal to F1 upon F2, assuming we've closed up this side of the triangle. 2 times 10 raised to the power 11 is F1, 3.6 times 10 raised to the power 11 is F2. By the time you do this simple division, you're going to obtain 2 all over 3.6. To obtain the angle theta, we take the tan inverse of the right hand side. It's just like dividing both sides by tan. If we take the tan inverse of this, the angle comes out as 29 degrees. That means the angle here, theta, which the resultant makes, is 29 degrees. This is south, this is east. So we have south, 29 degree, east. So we can say, therefore, that the resultant force has a magnitude of 4.12 times 10 raised to the power 11 Newton in the direction of south, 29 degree, east. This is an example of compass bearing. We will learn more of bearing in mathematics later, but here, this is the answer to the question. Very simple, and I believe you enjoyed it. If you did, here is a simple one for you to do. What is the force and direction of the force on this 15 coulomb charge? And when you get the answer, please put it in the comment section and I'll be there waiting for you. Thank you very much for watching this video and for supporting Knowledge Base, and see you in our next video.